CAT 32 bonus lecture number 6. Okay, so there is no assignment for this lecture, but there are some topics here that I want to cover. And just to make this lecture sound exciting, I decided to call it the bonus lecture. It's like the bonus round, but no points. All right, so let's go on to the next slide. Okay, so quick review how to save using save management and propagate. I need to emphasize this. Okay, so let's say you've been working on the motor-based assembly and most likely you downloaded the hardware either from what I gave you from the email, or maybe you downloaded your own hardware from the internet or created your own. So chances are you might not have all these CATIA part files in the same folder. Some might be in the download folder or on the desktop, especially if you downloaded your own hardware from McMaster or Carlane.com. Okay, so to guarantee that all of this is in the same folder, especially if you're going to email a copy of your files to another engineer, or maybe to a shop that's going to make the parts for you, or maybe you're going to download it onto a flash drive to give to another engineer or another department. Okay, so let's quickly go over save management. Okay, so we're going to go to File, Save Management. And make sure you go to the top assembly, in this case the motor-based assembly. And you can see the preview here on the right. Okay, so currently it's on my flash drive, but let's say I wanted to save a copy on my desktop. Okay, so I'm going to go Save As. So make sure you save as for the top assembly. Okay, so I'll go to the desktop and I'm going to create a new folder. And I'll call it motor-based assembly. Okay, so new folder on my desktop. Okay, so I'm going to hit save. Now, even though I hit save, it's not going to transfer it yet, not until I hit OK. So I hit save. Okay, so it is going to save it now on my desktop. It hasn't yet, not until I hit OK. But before we do, we're going to hit propagate. So it's going to send a copy of all these files. So it's going to create a copy to place in this new folder of all the files that make up this assembly. Okay, so we're going to hit propagate and keep an eye on the location column 321 propagate. So it's going to create a copy of every CATIA file and place it in the same new folder as the top assembly, the motor-based assembly. And once I hit OK, it'll transfer a copy to that folder, and OK. And there it is, transferring. And just a reminder of how to zip a folder. So if you're going to email this, so it eats up less memory, I'm going to right click and we're going to compress it. So compress our motor-based assembly folder. There it is. It creates a duplicate folder. It's compressed, and I want you to notice that it eats up. Look at the size of this file, compressed versus the regular folder. It's almost about a third of the size. The zip folder is 1/3 the size of the regular folder. Okay, so now you can attach this to an email, or maybe move it onto a flash drive to give to someone else. Okay, so let's go back to our lecture. Okay, so just wanted to emphasize, make sure to use propagate so you can send a copy of all the files to the desktop, or to your new folder, I should say. All right, so again, if you want to compress a folder, you just right click, send to, and compress it. All right. I want to talk about generating a CAT part from a product. Okay, so sometimes you want to take an assembly and save it as a single CATIA file. Okay, so let me give you an example. So let's say I was going to work on the part that attaches to the brackets, and here are the holes for attachment. Most likely I'll use some bolts and nuts to attach something to the mounting brackets. But let's say my computer is slow or these files are just too large in size and it's slowing me down. What you can do is convert it to an all-cat part. Instead of having to open up all these CATIA files to see the assembly, you can create an all-cat part. Okay, so let me show you a good example of where I've used this in reality and work. Okay, so this company, we were working on this prototype aircraft. The rudder and the horizontal stabilizer were already designed, but they wanted to make some changes, some major changes to the horizontal stabilizer and the rudder. There's a carbon fiber composite prototype two-seater. It could be a three-seater aircraft for training pilots. So they asked me to basically start from scratch and create a new rudder and a new horizontal stabilizer, one that could be adjusted so we can find the angle of attack. So this horizontal stabilizer, typically it's fixed, but for this prototype, we're going to allow it to rotate slightly so we can find at which angle we can set the horizontal stabilizer to be more fuel efficient, and also design a new rudder. All right, so I had to constantly open up the fuselage because the rudder attaches to the fuselage, the empennage section. And also when I was working on the horizontal stabilizer, I would need to open up the fuselage assembly. And it would take me about 20 minutes to open up the fuselage assembly. And so what I would do is I would convert it to an all-cat part. And we also had interns, young interns from the local colleges or universities. We would have them every Friday afternoon take these large files and convert them to all-cat parts. And then I would open up the all-cat part, either converted by me or by one of the interns. And it would just eat up less memory. So let me walk you through that. Okay, so if you or somebody that's assigned for your department or your company to convert an entire assembly into a single CATIA file. Okay, so here's what we're going to do. Let's go back to our slide. We're going to go to our assembly. Make sure this is active. Double click at the top of the tree. And then we're going to go to Tools, Generate a CAT part from a product. Okay, so this is our product. And then we're going to generate a CAT part, a single CATIA file from the assembly. It'll be a non-smart or a copy that's non-smart. Okay, so let's go ahead and do that. So we're going to go to Tools. And again, make sure first that this is activated. Go to Tools. And we're going to go to Generate CAT part from Product. And it's going to translate. So in 3, 2, 1, click. Oh, forgot I need to give it a name. So it's going to take on the name of the assembly. And it's going to add the underscore all cat part. You can remove this if you like. I just leave it in there. Okay, so once I hit OK, give it a few seconds and it's going to generate a new file. 3, 2, 1, and OK. And it's generating a single CATIA file. And there it is. So this is a single CATIA file. And I want you to see that it took the knuckle, created a non-smart solid, took the shaft, created a non-smart solid. So you lose all the history of how that shaft was created, the sketches, the pat commands, the pocket commands, the chamfer commands, etc. So if you look at all these components, they've been converted to non-smart part bodies within one single CATIA file. This is the main part body, which is empty. And all these are secondary part bodies, non-smart. And the cool thing about it, again, is that it eats up less memory. Now, one thing that you can do is, even though the brackets have lost, for example, let's take a look at this bracket. Even though we lost the history of how this bracket was created using sketch, pad, using sketch, pocket, using hole command, etc., using fillet command, we can make new history. So if I wanted to make alter this part, make a change, I can always right click, define. By right click, define, you're telling CATIA you're going to make changes to this part body. Okay, so if I want to add a hole, for example, you're going to see it's going to create new history. There it is, hole command, and OK. So even though this solid has lost knowledge of self, lost knowledge of history, from here on you can create new history. Okay, so this is smart, and this is non-smart. Anytime you see a red lightning bolts tell you it's non-smart. That means the solid or a surface or a curve or a point or any geometry has lost knowledge of self. It doesn't know its history. All right, if I wanted to now create a hole on this one, okay, so there it is. I just have to right click on it, center graph, and it'll take me straight to it. So right click, center graph will take me directly to the location of it in the tree. There it is. So if I want to make a change to this bracket, the right hand bracket, I can right click, define. And again, if I want to add a hole, and there's a new history here now, a new feature, hole command. Okay, so this is an all-cat part, and you can save it as again, it's a single file. If you wanted to, you can always file, save as, and save it in the same folder. And it's better to include that all-cat part extension, and it is going to save it as a .cat part file. Okay, I'm not going to save it. I don't need to. I'm going to go ahead and cancel it. And I'm going to go ahead and go window vertical just to compare it to the original one. So on the right, we have the original one, the smart one. So if I wanted to know how was this slot created, I can always right click, center graph. Oh, it was created from symmetry off of the left-hand side. Okay, so it's telling me, hey, anytime you see turquoise, that means it's linked to another CATIA file. So the right-hand side bracket is linked to the left-hand side. So I can right-click, center graph on that slot, and here it is. There was a sketch drawn and then a pocket to create that slot. All right, so this one has history, and again, it eats up a lot more memory. And it comes in handy when you don't need, if you're not working on this, but you are going to work on the part that interfaces or mounts onto these brackets. To save memory, save it as an all-cat part as shown on the left. All right, so I'm going to go ahead and close this all-cat part, and I'm not going to save it. Okay, I can maximize my window here. All right. Okay, let's go on to the next slide. All right, so you can save your files as step files. You can save them as IGES files or a CATIA graphic representation, a .cgr. Let's first do a CGR and then we'll come back to step and IGES. Okay, so CATIA graphic representation or .cgr. So we're going to take our assembly and save it as a non-smart blob. Couldn't think of a better word, but think of it as a blob. Here we go. So we did an all-cat part earlier. Now let's do a CGR. So we're going to go File. Make sure you double-click at the top of the tree because we're going to do the entire assembly. So we're going to go File, Save As. So I cannot generate a CGR and open it right away. You have to generate and save and then open it. Unlike the all-cat part, which first generated the all-cat part and then you can save it. Okay, here it's going to generate it and save it, and then you have to open it. Okay, so we're going to go to the drop down here and look at all the options we have. We can save it as a step, an IGES, and so on. So I'm going to save it as a CGR, CATIA graphic representation. Okay, and I'm going to go ahead and save. Okay, so it generates it, saves it, but it doesn't open it. So now I need to now go to the folder. Okay, so let's go to the desktop. Let's go to the motor base assembly. Okay, and there's that CGR file, CATIA graphic representation. And your instinct will be to either double click and open it or drop it into CATIA. Let me first show you what most likely you're going to do. You're going to go File, Open. You're going to go to your CGR. Let's go to the desktop, motor base assembly folder. And you're going to go to CGR and you're going to try and open it. And watch what happens when I try and open the CGR. It's going to say invalid, error. It's telling me, hey, you cannot just open it. You need to insert it as an existing component. In other words, I need to insert it into an assembly. Okay, so I'm going to close it. I'm going to create a new assembly file from scratch, a new one. File new. And I'm going to go to product. So I'm going to create a new product file. And OK. So it'll start a new one. OK, so now, again, the error message told us to insert it. Here's the insert. Here's the yellow arrow. Click on this one. Insert existing component. It's existing. It's in our folder on the desktop. Click. You have to tell it where. If you don't know what to do next, read along here at the bottom. It's telling you, hey, where do you want to place it? Well, there's only one choice. Because if there was a bunch of assemblies, you would have more than one choice. Here, there's only one, but you still have to click it. Okay, there it is. There's the CGR that we're going to insert. Click on it and open, and it'll insert it. 3, 2, 1, open. And there's our CGR. Okay, unlike the all-cat part, there's no part bodies. If you open it, click on the plus, it's just a blob. So I can't do anything with it. I can't drill a hole. I cannot create a new pocket. The only thing that it's good for is for interrogating the model. So like a planner or an estimator for a company will open up the file and give the customer an estimate of how much it costs to make all these parts and assemble them, what material is going to be used, etc. And it's also good for measuring. Okay, so you can always use your measuring tools. And I'd say over 90% of the time it'll give you a good, accurate, or I should say an exact measurement. If it doesn't give you an exact measurement, it'll give you something close to accurate. All right, so again, this is a CGR. It's just a blob. Eats up less memory. And I believe you can only open it in CATIA. All right, so let's go on to, actually, let me go ahead and go vertical so I can see both. So here's the smart one with all its features and a history of how it was made, etc. The one on the left, the CGR, is just a blob. Okay, there's nothing I can do with it other than interrogate it. In other words, look at it and take measurements off of it. Okay, I'm going to go ahead and close this. I'm not going to save the assembly. Okay, so now let's go to Step Files and IGES. Okay, so we can save it as a step file. And step files, you can typically open them in any type of 3D software like CATIA, Inventor, Unigraphics, ProE, and other 3D softwares. I believe SolidWorks also opens these files. And also Mastercam. So if you ever worked in a machine shop, most of the times they'll use Mastercam to do the NC programming, to machine the parts. So if I wanted to send the motor-based assembly to the NC programmer, that most likely will use Mastercam to do the programming, I would take my CATIA files and save them as step files. Step files will create non-smart solids. And also I would send them a copy of an IGES. IGES will create non-smart surfaces of the solids. Okay, so let's go ahead and create step files and IGES. All right, so you can do it for the entire assembly or for each individual part. Typically, I would open up the part individually and then save them as a step or an IGES. I'm going to go ahead and just do the entire assembly. Okay, so I'm going to go to File. So first, double click at the top of the tree. Make sure the top assembly is active. Go to File, Save As. Go to the drop down, and I'm going to save it as a step file. Okay, so it's going to generate it, and it's going to save a copy of it in my folder and click Save. Oh, I don't have a license. So unfortunately, I don't have a license to create a step file. On campus in our computer lab, we do have a license to export step files. So I cannot generate a step file, but I can open an existing step file. Okay, so I'm gonna have to cancel this. I don't have a license on my personal computer. Okay, so let's go to IGES, the next one. Again, the difference between an IGES and a step is step, it'll create non-smart solids, just like an ALLCAD part. IGES will create surfaces, not solids. Okay, so let's go back. Okay, so I'm gonna just do the base plate. Let me open up the base plate in its own window. I don't need to do the whole thing. Okay, so if I was done with this base plate and it's ready for NC programming, I would save this as a step file and an IGES file, and either through a flash drive or on the network, give copies of this to the NC programmer. Okay, so I go File, Save As. And I would save it as a step file, which I don't have a license to do. But I can do IGES. I don't think you need a license for converting to an IGES file. And save, and it's going to generate it. There it is. It's generating and saves it. Okay, so now I can go ahead and open it. File, Open. And there's the .igs file. Click on it and open. Now it's going to translate it to something CATIA can read. And same thing with the NC Programmer. NC Programmer would typically use Mastercam and sometimes SolidWorks to do their tool design. And they can open up the file and they can use this file to program. And I want you to notice that it didn't bring it in as solids, but as non-smart surfaces. And just to prove it to you, I can hide one of these surfaces. I'm going to right click hide, and we can look inside. As you can see, we can look inside the part. You can see it's hollow, it's just surfaces. One thing I do want to point out is anytime you convert a file to an IGES or maybe a step file, sometimes it doesn't translate the fillets very well. So one issue that we were having was when we were doing tooling for the winglet, the tip of the wing. So if you go back to, we were working on, I think it was a 787 Boeing aircraft, and the wings, you can see they start off a lot wider here. And it starts tapering. So this is the leading edge of the wing. It starts tapering, then it would twist, then you would have the winglet. And we would have a lot of trouble getting these fillets here to translate over. So one of the issues we would find is, let me go back and unhide this one. When you would translate this to an IGES, sometimes it would be patches missing, and it would typically be at the fillets. You would see things like this, just missing. Okay, I want you to be aware of that. It's a big problem. It's a big issue, especially with fillets that are tapering and turning or twisting. And you would have to go in there and fix it. Or maybe change your settings for translating your IGES and step files. Since I'm here, one thing I forgot to mention is lighting. Maybe you are aware of this. Most likely you have one light bulb on. I have two of them. Go to View, lighting, so most likely you have one bulb on. You also have the option to turn off all the lights. Here's one light is on. Here's two of them, makes a big difference. You can also increase the intensity if you like. Reflection also. And you can also change the direction of the light by pulling on these vectors. So I just left mouse click and hold, and you can change the direction of the light, as you can see, like a sunrise, right? Sunset and so on. And especially neon, if you're working on complex surfaces like in aerospace or automotive, you want to see the light reflection off the surface. If it's a nice clean surface, then you'll get nice zebra stripes or neon lights or neon stripes. If these zebra stripes for some reason break, that means there's something wrong with the surface. So here we have this zebra stripe that all of a sudden makes a sudden turn. That's okay as long as it stays connected, but if there's a break between this light and this one, that tells you there's something wrong between the transition from this surface to another. That's something that's covered in CAD 37 surfacing. All right, so let me go to two lights and okay. Another thing, let me go ahead and close this. Okay, so I'm going to close this IGES. I don't want to save it. Let me close this CATIA part. Another thing that you may not be aware of is view, render style. So right now it's parallel, but I can go with perspective. 3, 2, 1, perspective. And this is how you would actually see it on the real world, right? Imagine you're driving down a street or walking by a building. This is what it would really look like, which is pretty cool. Sometimes when I need to get inside a tight spot, I go to perspective mode. Helps out when you're trying to especially put some type of constraint between two small pieces or a small piece of hardware and a large piece. And we can go back to view, parallel, view, render style, parallel. Okay, so let's move on. Okay, so that was IGES. Sorry I couldn't do a step file, but I can open a step file, which I'll demonstrate towards the end of this lecture. Okay, so creating a non-smart part body. All right, let me go back. Actually, I'm going to go back to the base plate. I'm going to go ahead and use the base plate. I'm going to open up in its own window. All right, so let's say your boss told you to make some changes, but you want to keep the original one as a reference, just in case you need to go back to it. So one of the things that I do is, let's say I was very happy with this design, but you need to make some changes. Maybe you want to go in a different direction, but you're not sure if you're going to come back to the original. So what I would do is just make a copy. So I'm going to right click on the part body and go ahead and close this. I'm going to right click copy. And I'm going to go to the top and right click paste special. Paste special. As a result, I don't want to link. If I link it, then if I make any changes to the original one, then the non-smart one will update because of the link. I don't want to link, so I'll just say as a result, no link, and okay. So there it is. There's the non-smart one. Let me hide the smart one, the purple one. Okay, so this is the non-smart. And I can go ahead and hide it. And I'll go back to the original one and make changes. Maybe I need to move the tabs over, for example. I can now go ahead and make changes and keep the old one as a reference. at the end of the day, or maybe if I'm satisfied with the new design and I don't need the secondary part body anymore, the copy, I can always right click and delete it once I'm done with it. Okay. Okay, so that's what I was demonstrating here. You can always take a part body, right click, copy, paste special as a result, and it'll create a non-smart copy. All right, so let's go on to the next slide. Okay, what happens if you change the name of a file before you open it in CATIA? Okay, this can cause problems. Let me go ahead and close this. I don't want to save the changes. Okay, so let me go ahead and use the clamp assembly as an example. Okay, so I'm going to go to my top clamp assembly. Now these are called ghost files. So one thing that I did before opening the file was I changed its name. So it's telling me, hey, we can't find the clamp strap and we cannot find the hook clamp. Okay, so here it is, hook clamp and clamp strap. Okay, so if I go back to that folder, I want to show you what I did before opening it. So let me go ahead and sort by type. Okay, so what I did before opening this, before I started lecturing, was I took the hook clamp and I renamed it as hook clamp X. And I also took the strap and called it clamp strap X. So I renamed it before opening it, and CATIA cannot relink to this new name for your file. Now, other softwares like SolidWorks will automatically link to it. CATIA will not. It wants you, the user, you, the designer, the engineer, to link it. It doesn't want to make the mistake of linking to the wrong file. So again, unlike SolidWorks and other softwares, it will automatically relink to the file even if you rename it, but not CATIA. I think it's because CATIA doesn't want to be responsible for linking to the wrong file. Okay, so there's a few things we can do. So I can change the name here. I can go back. I can change it. I can just go back to clamp strap. Okay, let me click away, and then I can open it. Once I open up clamp strap, it'll recognize it, and it'll relink our assembly, and this ghost file will then turn into a colored file. Okay, so here we go. Let's go ahead and open up the clamp strap. Double click. Okay, so there's the clamp strap, and if I show you the clamp assembly, it now recognizes it, right? There it is. It's like, oh, hey, it's open here in a separate window. So it loaded the clamp strap. Is no longer a ghost file. Okay, so once again, if you see something like this, it's telling you, hey, something happened to your file. Either you moved it or you renamed it, and we cannot link to it. Okay, so another way to fix it is to go to Desk. You can go to File, Desk, or when you get the error message, you can click on the Desk button here, and it'll pop up this window where you can link it yourself. So if it can't link to this file, for example, once you click Desk, this window will pop up with all the links, and then you can right-click Find, and it should take you directly to the folder where it was originally saved. Okay, so let's do that with the hook clamp, just to do it a different way. Okay, so we still need to relink the hook clamp, but let's say this time you wanted to keep the new name, hook clamp X. Let's say you wanted to keep that name. Okay, so we're not going to rename it back to its original, but we do want to relink it. So we're going to click on Desk button, or you can go to File, Desk. Either one will work. Same thing. Okay, I'll just click on the button here, Desk, and it'll show me the links for the clamp assembly. Okay, so here are all of our links. Also, it's showing me the motor base and the clamp assembly. So let me go ahead and close this, and I'll reopen it. Let me close the motor base. Forgot I had the motor base open. Let me go ahead and close the motor base assembly. Do you want to save changes? No, I don't want to save. I'm just going to go ahead and proceed. Okay, so let's try it again. Let's go with File, Desk. Okay, so all I wanted to see was the top clamp assembly. There it is. So here are my sub-assemblies, the clamp strap, and then all the items that make up the smaller sub-assemblies. If there was a drawing for this clamp assembly, you would also have a link. So if you would check your link to your drawing or your links, it will link it to the top clamp assembly and so on. All right, so I need to fix this. Anytime you see red, it tells you it lost the link. If you see white, links are good. Okay, so we have an issue with this one, so I'm going to right click. I'm going to find it. And it should take you straight to the folder where it originated, and there it is. So there it is. There's the hook clamp, and it'll relink once I hit open, and it'll relink it. There it is. And it will also, if you go back to the clamp assembly, it will then also load it. It's already loaded now, as you can see, there it is. Okay, so the hook clamp is no longer a ghost file. We see color, and it's relinked. And just to play it safe, you would want to save your assembly. Since it's linked now, since it was able to relink it, you have to save it to guarantee that you stay linked to your clamp strap and your hook clamp file. All right. So once again, if you see red, that means ghost file. It cannot find the file. One good example is some of you will forget to send me all your files. So once you finish your motor base assembly or your clamp assembly, you're done, and you only send me your motor base assembly cat product file and not send me all your other files. So when I open it, it opens up as an empty binder. So think of it as sending me your binder, your motor base assembly, and forgetting to include all your files in that binder. So this is the issue I'll have if you don't send me all your files that make up your assembly. So once again, if you see red, so red means broken link. If it's white, good link. If it's black, it means it's dormant. So sometimes if you're dealing with large files, you can open up parts as dormant, and you can turn on cache mode to be able to do that. Let me go ahead and demonstrate that. So if you want to go to cache mode, you can go to Tools Options. Let's see, compatibility. Might be in the wrong file. I'm in the wrong area. Let's see. Let me go ahead and open up one of your older lectures. I forgot where to get to cache mode. Let me go to one of the older lectures. Okay, so if you're dealing with really large assemblies, one thing you can do to reduce your file size is to turn on cache mode. So here it's off, so we need to go to infrastructure. There it is, infrastructure, product structure. Go to the cache. Some refer to it as cache or others call it cache. So cache management tab, and we're going to work in cache mode. Okay, so let's go ahead and go back, go to infrastructure. There it is, cache mode. And it's telling me you're going to have to restart CATIA, so okay. So let's go ahead and close these. No, I'm not going to save. Actually, I should if I want to save my links. Okay, so we're going to restart CATIA. So we can go into cache mode. Okay, so what this does is it'll bring in all your parts. For example, the motor base assembly. It'll bring them in as dormant and it helps save memory. Okay, so when you open it, you're going to see it's going to look a little different. It's going to look almost like a shell when you hover over it. Let me close this file. Okay, and let's open up the motor base assembly. And I don't know if you saw that it said, hey, we're bringing them in as CGRs. It almost looks like a CGR. See, when you hover over any of the parts, it looks almost like a shell. So if I wanted to work on the base, for example, let's say I open this and I wanted to work on the base. Notice there's nothing. I click on the plus and it's almost like it's non-smart, like a CGR. So right now it's like it's in CGR mode. It's in dormant mode. But if I wanted to work on it, I can always double click on it here on the tree or double click on the actual solid. I'm going to double click and watch what happens here on the tree. It loads the history. Okay, so if you're only going to work on the base, you can leave everything else dormant and it doesn't slow down your computer. You save memory. Okay, so if I was to work, if I wanted to work on the mounting bracket, if you hit the plus once again, you'll see that there's no history. It's like, hey, what happens to its history? You can either double click on the solid or double click here on the tree, double click, and it'll load its history of how it was created. Okay. One thing you can do is always go back. If you wanted to place it back in dormant once you've done working on it, you can always right click and you can go to visualization mode. You can also activate it by going into design mode. Okay, so that's another option. Okay, so that's cache mode. Comes in handy, especially when dealing with large files. All right, so let's go on to the next item here. Okay, when you're working on an aircraft, you're going to be looking for the CG, the center of gravity. So if your boss says, hey, I need the CG for this aircraft or this fuselage, or maybe on some tooling you're working on, because maybe you need to lift the fuselage. You're going to use a crane or something to lift something heavy, and you need to know where the center of gravity is. Okay, so if I go back to this picture here, typically the CG will be near the pilot along the center of the fuselage. That's where it's balanced. Okay, so typically you want the CG once again where the wings are and where the pilot and passenger are sitting right in the middle. Just helps balance the aircraft. That's why one of the problems is if you load so here's the luggage door. If you throw in too much luggage in the back and the tail section, this may make your aircraft want to rotate and you can lose control of the aircraft. So it's always important to know where the center of gravity is for your aircraft. Okay, so how do we find the CG? And also how much it weighs. Okay, so here under mass, it's telling us how much it weighs. So we're going to use this icon, this inertia icon, command to find the center of gravity and to also find out the weight. Okay, now I have not applied any material to my parts. So let me go ahead and load these up into design mode. I want to go into design mode and wake all of them up. I don't want them to be shells. Let me double click at the top. And I'm going to go into design mode. So it's loading all my files. So all of them should be awake now, showing all the history. So you can see there it is. And I need to do this to be able to find the CG and the weight. Okay, so I have not applied any material to my parts. But typically you would apply, whether it's aluminum 6061 or steel or aluminum 7075 or 2024 aluminum. You apply your material and you would be able to get the weight of your assembly or a single part if you like. Okay, so let's take a look at the inertia. Measure inertia icon, there it is. So you can measure an individual piece if you want. Let's say I wanted to just measure the base. Okay, so I'm going to go to inertia, measure inertia icon, click, and I'm only going to click on the motor base. Okay, so it's a little hard to see, but you see this red line, this green line, and this blue line, and that's the center of gravity. That's the CG for the base. If I wanted to select more items, you're going to see how the CG transfers over. So if I want to also include the bracket, and hold on to the control key, you're going to see the CG move. Let me go to the next bracket. You'll see the CG adjusts. So it's finding the CG for the base and the brackets combined. Okay, if I want the entire assembly, I can click at the top and it'll do the entire assembly. So there's the CG of the entire assembly. Okay, so a cool thing about this is that it can create geometry. So if you wanted to know where that CG is visually, it'll create a point. So you can go to Create, Geometry, Create. Hey, do you want to insert a new CAD part that'll save that point? Or you can save it into one of the existing ones. I'm like, no, I want to save it into the motor base CAD part, so I don't have to create a new CAD part. Okay, so I'm going to hit OK. And I want it to stay linked. So if something changes or shifts, I want the CG to also update. So I'll keep it linked, associative, or you can say non-linked. Okay, so I'm going to keep it linked and I want center of gravity. And OK. It's hard to see, but there's a point there. Let me go ahead and open up my... So in my motor base file, it created a geometric set. Typically, that's what you use to place wireframes, such as points, curves, lines, and also surfaces. Okay, so there's that point. There's that CG. You can see it right there. It's a point. Okay, so now let's say I wanted to know how much it weighs. Okay, so this is the default. Now, I changed my units to give me pounds, inches cubed for density, and pounds for mass. I use inch squared for area and inch cubed for volume. You can change that if you don't want kilograms or millimeters for your units. Go to Tools Options. Go to Tools Options, go to Parameters and Measure. Go to Units. So in length, I went from millimeters to inches. Then we have mass. I went from kilograms to pounds. Volume, I went from millimeters cubed to inches cubed. Density, I went from, I think it was kilograms per cubic meter, I guess it was, and I went over to pounds per cubic inch. And you can go down. There's also volume. So I changed volume from meters cubed or millimeters cubed to inches cubed. So I went with inches and pounds. And there's a lot more other units you can change. As you can see, I'm only going to change the first few. Just way too many to change, as you can see. And hit OK. I already have mine set, so I'll just hit cancel. Okay, so once again, let's find the weight of your motor base assembly. So we're going to go to the measure inertia of the entire assembly. And once again, I don't have any material applied to it, or else it would give me an accurate measurement for our weight. Okay, so just keep it simple so I don't have to go in and add weight to all my items. I'm going to assign it, I'm going to make it all steel. Okay, and steel has a density of 0.283 or 0.284 pounds per little cube, 1 inch by 1 inch by 1 inch. So one little cube of 1 inch by 1 inch by 1 inch of steel weighs 0.283 pounds. Okay, so I'm going to type in 0.283 or 0.284. And then click away, and you're going to see the mass change. So I'm going to click away. So it's telling me this weighs about 11 and a half pounds. Okay, so if we're using all steel, this weighs about 11 and a half pounds. Let's say your boss says, hey, let's make it all aluminum. Typically the hardware would be steel, but just to keep it simple, let's make this all aluminum. So aluminum, I would go in and change the density. Aluminum has a density of 0.098 pounds per cubic inch, and just click away. And watch what happens to the mass when you click away. And it's about a third, right, of steel. So it's about 4 pounds. Okay, so good little trick to find the center of gravity and to also find out the weight. Okay, I'll go ahead and cancel that. And by the way, there's the point once again for the CG of my assembly. All right. Let's go on to the next topic. All right, so this is going to happen. It may not always happen, but if you're at work and you're trying to open a file, so let's say I go to my desktop, and this is very common. It does happen. Let's say I go to my desktop, go to my motor base assembly. And let's say I want to open up my motor base assembly, and I open it from here. But instead of linking to my CATIA files here, it links to my files in my flash drive. So let's say my motor base assembly here on my desktop. So I'm on my desktop folder, motor base assembly folder, but it keeps linking to my flash drive files. This happens, and one way around it is to tell CATIA where to look first. Okay, so if we go back to this slide here, so if you want to change the order of where CATIA is going to look for your linked files, go to General, go to Document tab, and go to this window here. And first it'll look whatever's at the top. So when you open up a file and it's linked to maybe a hardware in the catalog, it'll look there first. Then if it doesn't find it there, then it goes on to the next one, folder of the link, folder of the pointing document, relative folder. Okay, so if you wanted to look within the folder of the assembly that you're opening, then you want to move this up to the top. All you have to do is click on it and then move it up the ladder. Okay, so you can change priority. Nowadays, if you work for a big company, chances are you're going to be saving it in Innovia or Smart Team or Team Center or in the cloud. Okay, but If you find yourself having issues connecting to your files on your hard drive, your desktop, or your flash drive, you can change the order here. Move it up and down by priority and then hit OK. All right. Now let's talk about Booleans. Okay, last topic we're going to talk about Boolean operations. So to get to Booleans, you're going to go to Insert, Boolean operation, and there's a few choices. You have assemble, add, remove, intersect, union, remove lump. I'll go over some of them, most of them. Okay, so what are Booleans? Okay, before I talk about Booleans, let me go ahead and show you an example of how things used to work decades ago. So years ago, before there was CATIA 5, CATIA 4, right? Back in the good old days when 3D CAD was still at a young stage, there was no hole command. There was no pocket command. There was no hole command. There was no sketcher. So you had to do things the hard way. So one of the things that we do cover in CAD 37, surfacing, we cover wireframe and surfacing. We cover wireframe because that was the old school way of modeling. Okay, so let me go ahead and open up an example of wireframe here. Okay, so here we have a solid, but we didn't use hole command, pocket command, and so on. We used wireframe to create this, and it's in the background. If I go to the background, here's the history of how that solid was created. Okay, so let me go ahead and hide the solid. Let me turn on the wireframe. I'm going to say show me everything in that geometric set. Okay, let me hide the surfaces. I don't have to hide all of them. But one thing I'm going to do is change the color of the wireframe so we can easily see it. So back in the days, you had to create wireframe. So you had to do points in 3D. And you also had to generate surfaces to create your closed object. So you're going to be able to close it. Okay, so you would say point and give it an XYZ coordinate, point XYZ coordinate, and then create a line between the points and so on. So you would create wireframe and then use surfaces to close it. So just like you see here, once you created your wireframe, you would create your surfaces. And that was the old school way of creating your models. And eventually that moved on to Booleans. Okay, so where we use solids to remove from existing solids. Okay, so here we created again, this is before Booleans. Here we draw a circle and we draw a surface to create our hole. So eventually it moved on to Booleans. So let me go ahead and demonstrate Booleans. So let me create a new file. Okay, so for example, if I wanted to place a hole into this block, this rectangular prism, I would have to create a shaft. I would have to draw a shaft and subtract it from this rectangular solid. Okay, so I'm going to demonstrate that. Okay, so I'm going to quickly just draw a quick rectangular prism. And I'm not going to constrain it just for time. And so, as you can see, I use Sketcher to draw this. I worked with some old timers, and I don't mean it in a disrespectful way. they would do things, these old timers would draw their lines using wireframe. They would put a point, line, instead of using Sketcher. And the reason they didn't use Sketcher is because they were used to doing things the old school way, doing wireframe. Okay, so I've seen old school engineers, designers, create their geometry without ever using Sketcher. They would just do wireframe and then do an extrude with surface. Okay, so I'm going to go ahead and do a pad. Okay, so there's my block. Let me go ahead and change the color. And then I'm going to insert a new part body. Okay, so I'm going to go to insert. I'm going to insert a secondary part body. Okay, so the first one is the main body. Notice that there's only one gear. Here it has a little mini gear on the side. This is a secondary part body. This is the main one on top. Okay, so I'm going to right click define. So anything I create now, it's going to go into this part body. The first part body, we use it to create our block. Okay, so now there's new part body. Again, right click define, and you'll see it's underlined. We're going to create a sketch now. I'm going to create it on that on the ZY plane. And again, just to save time, I'm not going to constrain this. Okay, I'm going to do a pad. Notice now it's in the secondary part body, my new sketch, and I'm going to do a pad. I'm going to mirror it so it goes in both directions. Oh, overdid it there a bit. Okay, there it is. So I want you to see that these are two separate solids. That's why I changed the color. Let me hide the shaft. Notice this is a solid block. Let me turn on the shaft and turn off the block. You can see this is solid all the way through. Okay, so in the good old days, if you wanted to create a hole, you needed a solid to remove from a existing solid. Okay, so what we're going to do is we're going to use the shaft to create a hole in the block. Okay, so we're going to go to insert, Boolean operation, and we're going to go to remove. Okay, so we're going to go to insert, Boolean, and we're going to remove. So we're going to remove the shaft. So click on the shaft, remove, and you'll see it here. We're going to remove body 2, the shaft, from the block. We can also click on the tree, remove body 2 from part body, and preview. There it is. There's the hole. Notice what happened to the tree. It added this feature remove, and it took part body 2 and placed it underneath the original part body. And okay, if you're happy with it. Okay, so that's a remove Boolean. Okay, I can always delete. Now, it's faster if you just do a hole command or a pocket, right? And it's less confusing. When you see something like this, it can be confusing as to, hey, how was this hole created? And you can't figure it out. Yeah, you can always go right-click define. See if we can go back to define here. There it is. Notice it turned blue because now it's under the part body. The part body is blue, so everything else underneath will be blue. All right, so let's go here and define. Okay, I can always delete this feature, this Boolean operation. I can delete it. I can right-click delete and say, no, I didn't want to remove. Delete it. It's asking me here, do you want to delete aggregated elements? That's part, in this case, the part body 2. I don't want to delete this, so I'm going to uncheck it. So I want to keep this, but I want to take out this remove feature, and okay. So it keeps it, or else it would have deleted this part body. Okay, this time let's do a join. We're going to join these two together. We're going to add them together. So we're going to go to insert Boolean. We're going to add them together. 3, 2, 1, add. Okay, so let's do it from the tree. We're going to add the shaft to the part body and preview. And notice it's now one solid. So it combined them into one. You can see now we have an edge here that we can, if we want, we can add a fillet, for example. So I can add a fillet on that edge here. So you can see we can add a fillet. Go ahead and delete it. Okay, so this is the old school way. This is before we had pocket and hold command. This is the old school way of doing booleans. Now, you're going to work for companies or bosses or departments where they're going to tell you never ever use booleans. So there are some companies that are strict about that. Then there's others that love using booleans, especially the old school designers and engineers that grew up using CATIA V3, CATIA V4, using wireframe and other softwares, using wireframe and booleans to create their parts. Okay, let me go ahead and delete this feature. And let's do another boolean type. So I'm going to delete the add feature. I want to keep the second part body, so I'm going to uncheck this and hit OK. Okay, now we're going to do a add and subtract all in one shot. So we're going to do an add and a remove. What I want to do is combine both of these two solids, but I want to remove this portion of the shaft, but I want to keep the one on the right, or the right side of it. Okay, so let's go ahead and do an insert boolean. We're going to do a union trim. So we're going to do a union with solids and then trim off the portions we don't want. Okay, so union trim. Union trim the shaft with the part body. There it is. Okay, now I want to remove. So, okay, I'm going to click in this box here. I want to remove this portion of the shaft. I'm going to keep the one on the right portion. So I want to remove this one. Click. Notice how it's transparent. So it's telling me it's going to remove the entire thing. Even though I only selected the circular surface, it's going to remove the entire thing because this cannot exist without the cylindrical shape. And hit OK. And there it is. I do want to caution you that with union trims, if things change, if you change your sketch or you change the size of the part body, the union trim sometimes has trouble updating. Okay, so you have to go in there and troubleshoot and reselect, like a face, for example, to remove. Just be aware of that. All right, so let me go ahead and delete the trim, the union trim, and OK. Oh, I forgot to uncheck it. Control Z, undo, right click, delete. Forgot to uncheck the box, and OK. And we're back to our two pieces. Okay, so those are booleans. And let me give you examples where I did have to do booleans. And again, typically somebody old school. So my supervisor loved using booleans. A good example was, let me show you here on the internet. So if you ever worked on interiors, okay, so here we have the A-pillar. So I've shown you this before in a previous lecture. Okay, so this is the plastic. Okay, so here's the A-pillar, and this is a plastic to cover the structural part, and it's covered in fabric. You can also have leather for your finish here. Okay, so not only for the A-pillar, but also other plastic pieces like the ones that go on the door or along the frame of the door, for example. They're going to have towers in the back as shown here. So here we have towers. So these clips here, These are things that we can order from a catalog or order online. And so these towers we would use repeatedly over and over again in different areas of the interior. So as to not to model these little V towers that accommodate these little clips, and these clips will then attach to the structural member of the vehicle at the A-pillar area. Okay, so here's where we use booleans. We would have these already pre-made solids, these little towers, that we could insert into our model and do a union trim. Okay, so just to demonstrate that real quick. So we would already have a file with these little towers. So I'm going to go ahead and model just a real quick tower. Okay, so I'm going to guesstimate the size here. Hope it's not too big. I should make it symmetrical, but just to save time. Okay, so there's the little V tower. So this would be in our catalog at work or our library, and then we would attach the clip, that little metal clip. Okay, so what we would do is take this part body and copy it and go to our plastic piece. Let's say this was our plastic piece. And we would paste special. Okay, it didn't land exactly where I was hoping, but let's go ahead and change this. So I'm going to demonstrate to you how we would combine these two different part bodies, again using booleans. I'm going to make this block a lot thinner. Okay, so just like we saw in the picture, we have these three towers that we had to add to our part. So we would use Boolean operations. Okay, so let's go back to CATIA. All right, so let's say it was in the wrong place and I had to move it over some. Okay, so if I had to move this over to the right location, one thing I can do is first define the part body you're going to move. Right click define. So let's say I had to move it over to the right. Let's say it was in the wrong location. Okay, so make sure it's underlined, right click define. And then we can translate it. So let's look for translation. And I want to translate it over with respect to the x-axis. So we're going to translate it. Are you sure you want to translate? Yes. And direction, I can either pick an edge if I want. I'm going to right click in here and pick X direction. Then I can use the green arrow if I want, or type in a dimension. And OK. There it is. Let's say I wanted to also rotate it. So you also have the option to rotate. We have rotate. Are you sure you want to rotate? Yes. And I'm just going to rotate about, let's rotate it about this edge. .90 degrees or 270, there it is. And you can also use axis to axis. That's another option you can use here. You can also move an object from axis to axis. You can say, hey, I want to move it from this axis to this axis, and it'll translate over also. Just to demonstrate that. And then I'll undo it. Let me insert a second axis. So here's axis. I can insert an axis right there. Hit OK. Then I'm going to translate it from this axis to this one. But before I do, let me flip this axis. I'm going to flip it. I'm going to take the Z and I'm going to flip it downward. So Z is going to be along this edge, and I'm going to reverse it just for fun. And OK. Okay, so I can also do a translation once again using axis to axis. Are you sure? Yes. I'm going to go with respect from this axis to this axis, and notice it's going to translate and flip it over. Again, because I flipped the Z direction, it also flips the object over. And OK. You can always deactivate. Let's say I have this axis to axis change, and I want to undo it, but I want to keep it just in case later on I want to come back to it. You can always deactivate it. Deactivate. Okay. You have that option. Okay, so now I'm going to do a union trim. So how would we join these towers with our A-pillar cover? We would do a union trim and Boolean using the Boolean operation. Okay, so we would go insert, Boolean, union trim. And I would say, okay, I want to join, it's already selected, the body 3 with the part body. And I want to remove the bottom portion. Oh, forgot to click in here first. Remove faces. I want to remove this portion. And you can see it's a little transparent there. You can see some transparency there. And okay, and it'll remove that bottom portion. So that's the way we inserted towers. So first you would locate it where you want it, and also how far do you want it to stick inward in this case. And you can remove the excess using, once again, the union trim Boolean. I don't recommend Booleans, but they do have their place, like in this example. So you're going to come across departments or managers that love using Booleans and others that forbid using Booleans. All right. Last thing I want to cover is downloading items from McMaster or Carl Lane. So some of you are already familiar with McMaster.com. So here you can download a lot of their 3D models or even 2D drawings as a PDF or .dxf file that you can open up in AutoCAD. So I use McMaster Car a lot, use a lot of the socket head cap screws. So I'm going to use socket head cap screw. You see these a lot of machine shops or metal forming shops. And typically you go with the black oxide coating. They're very affordable, very common, easy to find. Let me see if I can find black oxide. There it is, black oxide finish. There it is. And I'm going to go with right-handed threads, the most common one. Okay, and with thread, let's say I use a 1/2-13. So diameter of the shaft where we have the threads is 1/2 inch, and it's 1/2 inch diameter, and there's 13 threads per 1 inch length. Okay, so here we have socket head cap screws, 1/2-13 thread, and I'm going to go with the length of 2 inches. Look at the strength and tension when you pull on it. Okay, so let's say I wanted to download some of these. So you'll get a quantity of 10 for $13.55. That's a bargain, $13.55. And go to product detail. And here are all the specifications for this bolt and the standards that it meets and the strength. Okay, so once you download it, actually once you're ready to download, you can download a drawing if you want. download a PDF file, a .dwg AutoCAD file, or .dxf, and I save it as a step file. Okay, so I'll save it as a step. I'm going to go ahead and save it. I'm going to go ahead and open that folder. Oh, having trouble opening it. Let me go to my downloads folder. Maybe it's in there. There it is. So there's my... Okay, so what I'm going to do is I'm going to open it up in CATIA. File, open. So it's in my downloads folder. There it is. There's that step file. Now I don't have a license to convert to a step file, but I should be able to open it. Let's try it and open. Oh, I don't have a license. Oh, so no good for me. So let me look at another option. Let's see if it has IGES. Yes, it does have IGES. So I'll have, so I should be able to open up the IGES file. I'm going to go ahead and save it. Okay, so let me try it again. File, open. And I'm going to go to my downloads folder. There it is. There's the IGES and open. Okay, so I had to correct my mistake. I cannot convert nor open step files because I don't have a license. But in the computer lab, we do have the license for it. Okay, and there it is. And then you can save it as a .cat part. So let me open up a file that I do have where I opened up where I saved them as step files in the computer lab and then converted them into cat part files. So let me go ahead and open up another file that I have here. Oh, wrong folder. Okay, so here I do have an example of something I did design a while back. I went off of memory, something I had designed years ago. Let me open up this milling fixture. Worked at a machine shop. Under the direction of the supervisor. Supervisor told me what to design. I would do it in CATIA. And my supervisor also happened to be the NC programmer. So I would create it in CATIA and then save it as step files or CGRs so they can open it in Mastercam and do the NC programming. Okay, so a lot of the hardware you're going to see here I downloaded from McMaster and from Carlane. So I was able to open them as step files and then I saved them as individual cat parts. Oh, having trouble opening the file. Nope, still going. Let me close up some of these. I'm having trouble opening up this file, so let me go ahead and start CATIA again. Second session. And I'll just open up the individual ones. Oh, there it is. It did open. Okay, so there we go. We have it. Okay, so this milling fixture I'm going to show you. A lot of times you have old aircraft. So I think this was a 737 aircraft, decades old. It's pretty expensive to buy a new aircraft. So if you can find an old used one at a good price, the only problem is when something breaks, something goes wrong, then you need to replace the part. So in this example, there was a brake ring that we had a machine that would mount on here. And a lot of this hardware I downloaded from McMaster and Carlane, the bolts, the clamps. So the clamps I got from Carlane. You can tell because of the little CLs. See the CL all over the place? So I got these from Carlane. And the bolts I got from McMaster. Okay, so this mill fixture, we're going to take this L extrusion, mount it onto these blocks, and machine it. So this was meant to machine the outside of this L extrusion that I'm going to show in a few seconds. And then we can flip it over. So here it is. This is not the actual part. It was a lot more complicated than this. So I had to model the brake ring from old drawings. And we're going to machine it. Okay, so let's take a look at the hardware. So these clamps, you can see once again I downloaded from Carlane. You can see the little CL, and I downloaded it as a step file. I do have the option to open them and save them and open them as CATIA, but I chose instead to bring them in as a step file. So right now I'm in cache mode. Forgot I was in cache mode, so I need to double click on this. And here you can see all the individual part bodies. Let me go ahead and open the entire CATIA file in its own window. Okay, so we're going to look at this clamp. Again, I downloaded it as a step file, opened it, and then I saved it as a CATIA part. Okay. So here's the cool thing about working with a step file with a bunch of CAD parts is I'm able to translate things. You can see here I did some translations. I can always deactivate the translation. I can reactivate that translation. So you can see the bolt moving up and down. So sometimes you want to move things up or down for your assembly. So let's take a look at this one here. So I also translated the swivel foot. I can deactivate it. See, originally it was a little bit higher. I can activate it. And if I want, I can also change the length, as you can see, of the translation. So this is what's cool about dealing with step files with multiple CAD parts. You can always hide items. You can hide them or you can translate them. Okay, let's take a look at this hex nut. Same thing, I had to translate this hex nut. Okay, so let me go ahead and delete the translation and once again show you how to create a translation. So if I wanted to translate this hex nut, and also a good thing before I do that is add some color to your parts so they stand out. Maybe if you go with all purple, but different shades of purple for your parts, for example. And again, you don't want an entire assembly of this clamp. You want it as one CATIA file. So you can go to properties here and we can go to graphic and change the color, or we can do it from up here if you have your graphics toolbar active. I'll just make it green so it stands out. Okay, so if I wanted to translate this, right click define. And here's my translate. I want to translate. Are you sure? Yes. And I'm going to translate it in the Y direction. Okay, so go to Y, and you can just pull on the arrow or type in a number so you can see. And okay. Okay, this is what's cool about working with step files that you then convert into CATIA parts. And it'll have all these separate part bodies that you can translate or move or rotate. Okay. Okay, so actually this is the end of the lecture. Hope you enjoyed the bonus lecture 6.